the day 2 of CCNA journey. And today we have, we are going to discuss about some more topics related to CCNA, right? So, let's start with that. The agenda for day 2 is automation and programmability, how automation impact the network management, and traditional networks versus controller based networking, right? So this is what we are going to discuss today. So the very first thing is automation and programmability, right? Now, what is automation, where automation is needed, and why automation is needed in the organization? Like whenever you are creating the network, why there is automation needed? Okay, so the very first thing is you should know what is automation, right? And we are talking automation in terms of networking, right? So network automation, it is the process of automating the configuring, managing, testing, deploying, and operating of physical and virtual devices within a network. So, with everyday network tasks and functions automated and repetitive processes controlled and managed automatically, network service availability will be improved, right? So any type of network can use network automation. Hardware and software based solution, they also enable data centers, service providers, and enterprises to implement network automation to improve efficiency, reduce the human error, right? Lower operating expenses, right? So that is what, that is again other advantage of this thing. Now, how automation is done using programmability. So, what programmability is? So, it is what? It is the capacity of a device or a system or any application to be governed or configured using any software or other methods rooted in programming, right? So, what we have seen different scripting languages, right? Everyone has seen that there is Python, there is Ruby, right? There is Perl, there is PHP. So, there are some like Python, Ruby. These are what? These are your scripting languages, right? Now, using these scripting languages, you use the programming capacity of them, you instruct, right? Whatever you want to automate, so you create the loops over there, and then you define what to perform, right? So if I'm creating a program, let's say even uh, sometimes what we do for fun, we create viruses, right? So if I want to create a virus, what should I do? I have to create just a looping area, right? Or a looping thing, right? So a program which will just keep creating a loop, right? So if I'm doing this, let's say I'm writing a small program, right? So what we have, let's say I'll write uh, a function. Let's say the function name is main, right? Now I'm writing there start cmd and start paint, right? And then I'm writing go to main function. So what will happen? Main function will start getting executed. Yes. Then CMD will open, paint window will open, and then go to main. Again, it will go to main function. Yes or no? Can I say this is kind of automating the things, or automating the things that you need to perform manually, repetitively? Right? So sometimes what happens, have you, if you guys have heard about macros, what are macros? Now, macros are what? Macros are used in, these are just visual basic scripts, What kind of scripts? Visual Basic scripts, right? Where they are used whenever you want to perform any repetitive task in MS Excel or in MS Word, right? At that time you can create macros, right? So those, that is also a kind of automation that is happening, right? Perfect. Now, when I'm talking about the automation, right? How does automation impact your network management? What are the benefits of network automation? Now, if I'm talking about the benefits and write them here, benefits of automation, right? So when we are talking about the benefits of automation, it means it removes the risk of human error, right? Then reduces the workload for IT staff, then standardizes processes, increases resilience, and improves scaling. Perfect. Now, the first one removes the risk of human error, right? The manual processes which involve network devices, they are prone to errors. Even if your company has IT staff members who are capable of carrying them out, right? So it is highly probable that automating these processes will lower the chances of error occurrence. Even as network changes, they are successfully carried out on the first try, right? Now, aside from avoiding troublesome incidents resulting from manual changes, automated network configuration, it can prevent the network from breaking down, which will increase its reliability, right? Network security rules, they also become easier to enforce. It allows security audits to be passed without the need of further investigation, right? Then the second one is reduces the work load for IT staff. Now, since network related processes are run automatically, right? IT staff only need to see if these were triggered and implemented without any glitch. Although they must also remain on alert against the potential problems. They also do not need to document configuration changes in network devices, right? Like as reports that have this information are already available, right? So IT staff become more productive as they are able to focus on strategic initiatives, which will drive the business improvements, and it will attempt to make your processes become more efficient, right? Then there is standardizes processes. So within standard process implemented throughout the network, potentially troublesome situations within the infrastructure, they are avoided, right? Even as day-to-day maintenance activities, they become routine. Even if a network administrator leaves, the next person in line may be just as capable of handling administrator tasks as older or more experienced staff, right? So you should keep in mind that initiating a staff reduction just because your company has implemented network automation may not be necessary, since the processes still need to be run by capable person. Okay. Now resilience means that if there is any error in your network, right? If any error arrives or any problem arrives in your network, right? So how much fault tolerant it is. So fault tolerancy means that if something bad happens to your network, if some part of your network is stopped working, even then if it can give the same amount of availability or not, right? So automation, it increases the resiliency of your network. So optimal network performance, it is achieved through automated updates and changes that are undertaken regularly and without fail. So like in a manual setup where processes that take time, it may be overlooked because of the effort involved. So in addition, what a network automation does, it results in simpler management tasks due to the availability of tool which allow monitoring of network performance and alert so your staff to potential errors before they occur, right? So it will help them in preventing downtime and achieve service level agreement with relatively minimal effort. Yes. Then next is it improves scaling. Now what is scaling? Network automation, it can help you boost your IT infrastructure ability to scale even as it runs complex analysis based on the inputs from the various devices available within your network. So it allows speedy rollout of new services, right? Devices and applications based on established and reusable processes, right? So network automation, it also allows your network to handle increased usage demands before they impact performance, right? And this scalability would not be possible in manual networks without significant investment in time and manpower, right? So these are what? These are the benefits of network automation, right? Now, in network automation, when we are talking in terms of that, so how does it impact network management, right? So for that, what you have to do, you have to understand one thing, which is management planes. The data plane, the control plane, the management plane. So what we have three types of plane. The data plane, the control plane, and management plane. Yes. Now the first one, data plane. What data plane is? It refers to the task that a networking device does to forward a message. So, in easy words, anything to do with receiving data, processing it, and forwarding that same data. Whether you call the data frame a packet or a message, it's a part of data plane, right? Yes. Now, think about how routers forward IP packets, how how they do it, right? If I paste a picture here, everyone can see this image. Yes. Now in this what we can see that if you focus on the layer 3 logic for a moment, the host will send the packet to its default router, right? Which is R1. Now R1, which is the default router, does some processing on the received packet, right? Makes a forwarding decision or routing decision, and forwards the packet, right? To whom? Router 3, right? Now, router 3 and router 4 also receive, right? Uh, Process and they forward the packet, right? Now, broaden your thinking for a moment and try to think of everything a router or switch might do in receiving, processing, and forwarding a message. So the forwarding decision is it's a part of logic. The data plane is also called forwarding plane, that's why. But think beyond matching the destination address to a table, right? For perspective, there are some details, uh, some of the more common actions that networking devices does that fit into the data plane. Now tell me, uh, whenever we are sending data, the de-encapsulating and re-encapsulating of a packet in data link frame, yes or no? What do you guys think? When we are saying that the data is being sent, so de-encapsulating and re-encapsulating of data is happening. Now, what is encapsulating? You are adding the source IP, destination IP, you are adding source MAC address, destination MAC address, then you are adding the trailer to it. The trailer is checking if the data is coming free of errors or not, right? That is re-encapsulating and de-encapsulating of data, right? That also comes under the data plane, right? Then, whenever you are using routers and switches, right, you are creating, let's say, VLANs, right? Virtual Local Area Network. So in VLANs, there are two types of protocols that are used, right? In protocols, like from one VLAN to second VLAN, if I'm sending some data, right? So you have to tell, like I will tell if there are two VLANs, right? And from VLAN 1 to VLAN 3 I'm sending the data. So I'll have to tell that this data is coming from VLAN 1. Yes or no? Yes, correct. Now the thing is, whenever we are sending the data, right? So you have to do what? Cisco devices, they use their own protocol, right? So they will add a 30 byte like data to your data. That means 26 byte header will be added and 4 byte footer will be added to your data, which will just tell that this data is coming from VLAN 1, right? And when we are talking about normal devices apart from like the Cisco, right? So those devices they use 802.1q trunking protocol. Perfect. So 802.1q does what? It uses only 4 bytes header to tell from where the data is coming from. So routers and switches, they are doing this thing. So what you have to do, these headers, you have to add and remove these headers as well. So the adding and removing of these headers, they also come in data plane. Then what happens whenever I'm sending some data, right? Everyone knows how the data is found, if the data is for me or not. Let's say uh, I have some data, right? I'm sending some data to the target. So how the target machine will get to know if the data is for me or not? Let's say there are two devices. So if first device is sending the data, how the second device will get to know if it is for me or not? By checking the destination address, depend on destination IP address. Is it only IP or something else as well? MAC address also, right? So what happens whenever we are sending some data, right? So there is a sender side and receiver side. Yep. Now let's say like we have the OSI model. Everyone knows the OSI model. Perfect. Now in this OSI model, what we have, if I am sending some data, right? So that data will be going through every layer, right? Now when this data is going through every layer, so in the application layer, the data will be in plain text. So this is the sender side who's sending the data. At presentation layer, it will be encrypted and like from the sender side, it will be encrypted. Then a session will be created. Then transport layer, what will happen? The data will be segmented. Segmentation will happen, and it will be checked whether TCP will be used or UDP will be used, right? Then after that there is network layer. In network layer, what will happen? The IP address is added, right? So adding of these things, this is known as encapsulation, right? When we are adding, we picked up one segment which is E, and we added the destination IP address and source IP address to it, right? This is known as encapsulation. Now once destination IP and source IP is added, it is called packet. Then at data link layer, destination MAC, source MAC, destination IP, source IP was already there, and FCS, which is frame check sequence, which will look for errors in the packet, in the whole frame, right? That will be there, right? Now then the data is converted as to digital or analog. It depends on the type of medium we are using, whether it is wireless or wired, right? So that is your one thing, right? Then after that, the data is sent to the physical layer of the receiver. Now receiver's physical layer will do what? It will basically convert the data again into a format that other layers can understand. Then at data link layer, the destination MAC address and source MAC address will be checked, right? That if the destination MAC address written in the message is matching to mine or not, right? Now you have to tell one thing, who inside the target machine is checking if the destination MAC address is matching or not. So who is that exactly? Who's that layer? Like there should be someone inside your device who is checking that. It's the network interface card. So MAC address is the address of your network interface card, right? So it will check if the MAC address is matching to mine or not. If it is matching, then it's okay. If it is not matching, then it will drop the data. So once it is matching, the data, the destination MAC and the source MAC address, this layer will be, it will be shredded from this frame. Then the data will be sent to the network layer. At network layer, the destination IP will be checked again by the network interface card, that if the IP address is matching to mine or not. If it is matching, again, same thing will happen, right? What will happen? It will check if the destination IP written in the message is matching to mine or not, right? So this process which is happening, right? matching the frame's destination address to the MAC address table, matching IP packets destination IP address to IP routing table, everything. This also comes under your data plane, right? Then what else? Encrypting the data and adding a new IP header for VPN processing, right? What happens in VPNs? You have new IP header added. Why a new IP header is added? Whenever you are connecting to VPN, right? A new IP will be added, IP address, right? Whenever I'm connected internally to the network, I'm communicating internally. At that time, what IP will be used? Local IP, right? Now that means my private IP address will be used. But whenever I'm connecting to the internet, so my IP will be translated to a public IP, right? That is called network address translation. Yes. So in that network address translation processing, what happens? Your IP address gets updated, right? So at that time, your header will be changed, right? For VPN, virtual private network. Then, uh, next thing, we use access control list as well. Okay, so the thing is that when we are talking about access control list, I have created a list of IPs or list of users who can access what permissions they have for any kind of data, and if they can read the data, if they can write the data, if they can execute, or if they cannot do any single thing, right? So that is also under ACL. So when you are discarding a message due to a filter, right, that also comes under data plane. So all the items or all the things that uh, make up the data plane, right? So all those include all the actions that are done over the message, right? So whatever we have discussed, everything was in the data plane. That, think about it, that if everything is in data plane, what is in control plane then? Okay, now when we are talking about the control plane, so there are different kinds of information that the data plane needs to know beforehand so that it can work properly. For example, the routers, they need IP routes in a routing table before the data plane can forward the packets. Before forwarding the data, like what we are doing, we are forwarding in the data plane. I'm just looking at the routing table, forwarding the packet. But the routing table needs to be filled, right? There should be data in the routing table. Someone should have put some data inside the routing table before we can forward the packet, right? Then another example, the layer 2 switches. They need entries in the MAC address table before they can forward the frames to the destination port, right? The switches, they must use spanning tree protocol to limit which interface can be used for forwarding so that the data plane works well and does not loop the frames forever. So from the one perspective, the information supplied to the data plane controls what the data plane does, right? A router needs a route that matches a packet's destination address for the router to know how to route or forward the packet, right? When a router's data plane tries to match the routing table and finds no matching route, so the router will discard the packet. And what controls the content of routing table? Various control plane processes. transmission protocol. Okay. So the control plane, it refers to any action which controls the data plane, right? So most of these actions have to do with creating the tables used by the data plane. Tables like IP routing table, IP address resolution protocol table, which is ARP table, address resolution protocol, right? Then MAC table in a switch. So by adding, removing, and changing entries to the table used by the data plane, the control plane processes control what the data plane does, right? So we already know about many control plane protocols. Okay, so when we are talking about these things, right? So all the IP routing protocols, they are what? They are the protocols in control plane, right? Now there is one thing that the traditional networks use, right? So they use both a distributed data plane and distributed control plane, right? So each device has a data plane and a control plane, right? And the network distributes those functions into individual device, right? So let's say, let's paste a picture. Now check this. Now in this, what we can see, there is OSPF, right? OSPF stands for Open Shortest Path First. So the control protocol runs on each router, right? That is, it is distributed among all routers. So OSPF on each router then adds to or removes from and changes the IP routing table on each router. Once populated with useful routes, the data plane's IP routing table on each router can forward incoming packets, as shown from left to right across the bottom of the figure. Perfect. So the routing protocols like OSPF, EIGRP, right, RIP, the BGP protocol, then the ARP protocol, then Neighbor Discovery Protocol, which is NDP, Switch MAC Learning, the Spanning Tree Protocol, right? All these are the part of control plane. So without the protocols and activities of the control plane, the data plane of traditional networking devices would not function well. Routers would be mostly useless without the routes that are learned by a routing protocol. Without learning MAC uh, table entries, a switch could still forward unicast by flooding them. But doing that for all frames would create much more load on local area network as compared to normal switch operations. So data plane must rely on control plane to provide useful information, right? Then the third one that we have is management plane, right? Now everyone got to know about control plane. Everyone got to know about the data plane. So what is the management plane now? Now, what control plane does, control plane will perform overhead tasks that directly impact the behavior of the data plane. Now, the data management plane, it also performs overhead work as well, but that work does not directly impact the data plane. Instead, the management plane will include the protocols that allow network engineers to manage the devices, right? So, the telnet and secure shell, right? These are two of the most obvious management plane protocols. Yes. So to emphasize the difference with control plane protocols, think about two routers, right? Now, one is configured to allow telnet and SSH into the router, and one that does not, right? So both could still be running a routing protocol and routing packets, whether or not they support telnet and SSH, right? So whenever we are talking about software and software defined networking, the network programmability, it helps to understand think about the internals. Perfect. So switch is a device which is used to connect multiple more than two computers together, and the thing is it does not broadcast the data, it will send the data to the intended location only. So switches, from the very first days, switches they had to use specialized hardware, right, to forward frames because of the large number of frames per second required. So to get a sense of the volume of frames a switch must be able to forward, consider minimum frame size of an Ethernet frame, uh, the number of ports on a switch, and the speed of the port. Even low-end switches need to be able to forward millions of frames per second. So if a switch manufacturer is there and he wants to figure out how fast its data plane needed to be in new access layer switch with 24 ports, it might work through this bit of math. So the switch has 24 ports. Each port runs at 1 GB per second. So for this analysis, assume frames 125 byte in length, right? So to make the math easier, because each frame is 1000 bits long, with a 1000 bit long frame and a speed of uh, like 100,000 bits per second, a port can send 100,000 frames per second, right? So like a big calculation after doing all 24 million frames per second, it looks like a lot, right? So the goal here is not to put an absolute number on how fast the data plane of a switch needs to be given any era of switching technology. Instead, from their first introduction into the marketplace in 1990, LAN switches they needed a faster data plane than a generalized CPU could process in software. So hardware switches have always had a specialized hardware to perform data plane processing, right? Then the second thing is ASIC, the ASIC chip that we use in switches, right? ASIC stands for application specific integrated circuit, right? And that needs to perform table lookup in the MAC address table. So for fast table lookup, the switch uses specialized type of memory to store the equivalent of MAC address table, right? Then there is ternary content addressable table, TCAM, right? Which does not require the ASIC to execute loops through an algorithm, right? So that's the thing about the routers, the switches, right? They just need a better data plane. We got to know about management plane, so how automation impact the network management. First is you can see streamlined operations. So automation will empower network administrator to mechanize the repetitive task, like as we discussed, like configuring the devices, updating the software, everything will be done automatically. Then enhanced precision, so automated processes, they are less susceptible to human errors, right? Then efficiency will be more, right? So the procedures, the methods, they will be compared and executed much faster as compared to the manual things, right? flexibility will be improved, right? So, like improving the flexibility that you can easily implement new services and you can easily perform a reconfiguration of the network while doing the automation. Without automation, it will be difficult. Okay, so scalability means if there is, let's say, any network, right? In that network, if I want to increase the devices, right? There is a topology, I want to increase the devices, right? So that we can do, right? Then the next thing is the impact, network automation. So impact means fewer errors will be there, better network control, high uptime, more effective staff, low cost, increased agility, right? Now, when we are talking about the networks, so there is traditional networks versus controller based networking, right? So what are traditional networks? Now, when we are talking about traditional networks, these are also known as standalone or decentralized networks, right? So what they have, like they have individual network components like switches, routers, and they are autonomously managed, right? So this thing, each device, it assumes its distinct responsibilities like traffic forwarding, routing data mission, ensuring network security, right? Now, when we are talking about controllers and software, controller based networking, like software defined architecture, right? So these things they emerged in 2010, right? Approaches that change where some of the control plane functions occur. Many of those approaches they move parts of the control plane work into software that runs as a centralized application, and that application is known as. Now, when we are talking about software defined networking, this also came in 2010. So it tells the types of controller based networks, right? So also today you might see terms like these, like software based defined architecture, controller based networking, right? So when we are talking about the controllers and the centralized control, how it gives the centralized control, can anyone tell me? So most traditional control plane processes they use a distributed architecture, right? So every like if I give you example, every router runs its own OSPF, routing protocol process. To do their work, those distributed control plane processes they use messages to communicate with each other, like OSPF protocol messages between routers. So as a result, the traditional networks are said to use a distributed control plane, right? Then the people who created today's control plane concepts like spanning tree protocol, OSPF, EIGRP, and so on, they could have chosen to use a centralized control plane, right? That is, they could have put the logic in one place, running on one device or on a server. Then the centralized software could have used protocol messages to learn information from the devices, but with all the processing of the information at a centralized location. But what happened? They chose a distributed architecture. Now, there are pros and cons of using distributed and centralized architecture to do any function in any network, right? So if I talk about the control plane functions, they have a long history of working well with the distributed architecture, right? A centralized application can be easier to write than a distributed application, because the thing is the centralized application has all the data gathered at one place. And this emerging world of software defined architecture, it uses centralized architecture with a centralized control plane with its foundation in a service called a controller, right? Now, what is controller? The controller, or SDN controller, is the other name for it, right? It centralizes the control of networking devices. Now, the degree of control and the type of control varies widely, right? So, the controller can perform all control plane functions. It can replace the devices. Uh, then, alternatively, the controller, it can also simply be aware of the ongoing work of the distributed data, the control and management places on the devices without changing how those operate. And we can go on with it with many variations. Now, when we are talking about the centralized control plane and the distributed data plane, right? So there is one thing, southbound interface. So in your controller based network architecture, the controller needs to communicate to the networking devices. Yes. So in most network drawings and architecture drawings, those network devices, they typically sit below the controller. So there is an interface between the controller and those devices. And given its location, what happens? At the bottom part of the drawing, the interface came to be known as southbound interface, right? So several different options they exist for the southbound interface. The overall goal is network programmability. So the network interface moves away from being only a protocol, and southbound interface includes a protocol so that the controller and devices can communicate. So what it includes? It includes an API. Now, what is API? How will you use it? Application programming interface. So it is what? It is the method for one application program to exchange data with another application, right? So API, you can say, interface to an application program. The programs, they process the data. API will let two programs exchange the data, while a protocol exists as a document. Yes. So software or southbound interface, it is what? It is an interface between the program, which is the controller, and the program, which is on the networking device. These two programs can communicate with each other with the goal being to allow the controller program and the data program or the data plane forwarding tables of the networking device. Now, in a network architecture which is meant to enable network programmability, the capabilities of southbound interface and their API, it tells us a lot of things about what that particular architecture can or cannot do, right? Some controllers, they might support one or few southbound interfaces for a specific purpose. Others might support many more southbound interfaces. It allows a choice of southbound interfaces to use, right? So that's one thing. Then there is northbound interface, right? Now what can be northbound interface? Okay. Now think about the programming that is required at the controller and there is a fact that the controller can add entries to the networking devices forwarding tables. So how does the controller know what to add? How does it choose? What kind of information would your program need to gather before it can attempt to add something like MAC table entries or IP routes to a network, right? So you might think of some things like a list of devices in the network, the capabilities of each device, the interfaces on each device, the current state of every port, the topology, right? Which devices connect to which over what interfaces, right? The device configuration like IP addresses, VLANs, and so on, as configured on the devices. So controller does much of the work needed for the control plane in a centralized control model, right? So it will gather all sort of useful information about the network, like the items in the previous list. So the controller itself can create a centralized repository of all this useful information about the network, right? So the northbound interface, it opens the controller so that its data and functions can be used by other programs, and it enables network programmability with much quicker development. That's what is your northbound interface. Yep. Next thing, the main difference between traditional network and controller based network, the administrator, right? The administration, how administration is done. So the conventional networks or traditional networks, they demand autonomous management for each network device, right? The controller based networks, they will centralize the management, like we discussed about northbound and southbound, right? So they don't have like for any every specific device we don't do the administration, right? Collectively the administration will happen. Then there is expandability, right? So traditional networks, they encounter the hurdles in scaling up due to heightened device count. So controller based networks, they are giving scalability, which is facilitated by central controller, right? Then apart from that, there is flexibility again, right? So flexibility means anything you can accept the adaptability of the network condition. So device configurations are changing, right? Alterations are happening. All of those things we are accepting. We can accept these networks can accept, right? So controller based networks they can accept, but traditional networks they are a bit sluggish in that, right? Then there is network insight, right? Now, network insight means the traditional networks, they often grapple with providing a comprehensive network overview due to fragmented information dispersed across diverse devices, right? So, controller based networks, they utilize the controller to present an integrated network perspective, facilitating speedy issue recognition and resolution by the network administrators. Now in controller, the controller will configure the devices with consistent and streamlined settings. So the result will be faster and more consistent changes with fewer issues, right? Now just consider there is application centric infrastructure, right? So instead of configuring every port with access VLAN, right? Or making it trunk, adding routing protocol configuration, and possibly updating the IP access control list. All you have to do was to create some endpoint groups, right? We call them EPGs, right? And policies. In that case, the orchestration software that started the virtual machine could automatically create the endpoint group and policies, right? So the new paradigm of intent-based networking was enabled through the controller-based architecture. Then the automation features which are enabled by the controller's northbound APIs, they allowed third-party applications to automatically configure the network to support the necessary changes, right? So what it is, like some of the advantages are there, right? So it uses new and improved operational models that allow the configuration of the network rather than per device configuration, right? Then it enables automation through northbound APIs that provide robust methods and model driven data, right? Then it configures the network devices through southbound APIs, which results in more consistent device configuration, less errors, less time spent troubleshooting the network, right? Then it allows the DevOps approach to networks, right? So these are some other differences between the traditional network and yes, all good. Now we discussed about the automation, right? Now the automation in CCNA, it does not says that you should know how the automation is done. If you know that, that's good, right? But there is one thing that you should know in automation and programmability. So that is REST and JSON, right? REST is what? It's an API, REST APIs, right? JSON, it's JavaScript object notation, right? So the rest will give you the output in JSON format. You should know how to work with both of them, right? So in that, what uh, we use some tools, right? The tools that are there are Chef, Puppet, and Ansible, right? But before that, you should know about the RESTful APIs, the what kind of APIs are there, right? The variables, how to work with the variables. So a bit of programming is needed, right? So in CCNA, you learn that a bit of it, right? But not solely in depth, right? That how serialization is happening, right? And how you can use XML, the extensible markup language, right? All those things, right? So that's about the automation and programmability.